Hi everyone, this is Sumit K and welcome to my YouTube channel. Today I'm going to talk about Google Cloud VPC Network and this is going to be my first video of Google Cloud Network series. So this session or this video is all about the overall overview of the cloud VPC network, the various component around the VPC network like Google Cloud Subnet, firewall, routing, and interconnect, and we have CloudNet, VPC peering, and there are many component around it that we are going to cover in this video. So by the end of this video, you will have a very good and fair idea of Google Cloud VPC network. So Google Cloud VPC is one of the, or if I say VPC only, VPC is the foundation of any cloud provider, right? So if you are coming from the AWS background or if you are coming from the Azure background, then you must have used VPC or VNet in Azure, VPC in AWS, and VPC in Google Cloud as well. But but in this video, I'm going to talk about Google specific VPC network and how the Google Cloud VPC is different from the other cloud, and how can we set up Google Cloud VPC. So we'll see some few demo, but before that we need to understand what is VPC in general and what is VPC in cloud, right? So if I take an example of like how do you use traditional VPC in your private data center, right? Before cloud exist. So you used to have, let me just draw a diagram here. So you used to have your own data center like this, and then you have some racks and servers, and then routers, switches, and all you have like interconnected whatever using the WAN, the LAN, and you have the router, you have some firewall here, you have F5 load balancer, right? So all this thing is something that very complicated, right? It's everything everything that is managed by the organization, whether it is a physical network infrastructure or rack or firewall. So so your organization and your organization IT team is responsible for overall network. Now what happened in the cloud, right? Everything is remains same, right? Here also you have servers, you have, you know like all the network related things are managed by your cloud provider. So here the cloud, the network things is defined as a software defined, uh, the what we say software defined network object, or um, so this network is basically a software defined. All the objects like subnets, routing, firewall, all these things are, are treated as an object, right? So software defined network. Well, this is generic, right? So this is generic means it could be a Azure, it could be a AWS, it could be GCP, right? Or it could be anything, or Oracle or Alibaba, or anything, right? So this is the foundation, right? Every cloud manage their cloud network as a software defined network, right? And on top of that, it gives an ability to the customer to customize its network requirement based on the business needs, right? So um, so this is overall about the VPC network. And if I talk about why Google Cloud Network is different from the other clouds, if you are from AWS background, you must then you know that there is a VPC, which is a regional resource, right? And there is a VNet in Azure, which is also a regional resource. But in GCP, the VPC is a global service, right? And that's why it differentiate from the other clouds. So I'll show you why, like how GCP provides its VPC network as a global service. If I say global service, which means that the VPC in Google Cloud is spans over the regions, on all the regions where the Google Cloud has their own network, on having their own data centers. So it spans all over the region, all over the world. You have a unique um, global VPC. Okay, so basically, if I draw a diagram here, 1 second, let me show you an PPT here. So this is uh, the diagram of Google Cloud regions and zones. So you can see that that Google Cloud is spans over all over the world, and the Google Cloud has multiple regions and zones. And so regions is basically geographic location where you'll find Google data center, and Google data center are like a zone, right? So if a region, let's say in Mumbai, you have three zones, and Delhi you have three zones. The zones is equivalent to data center, and all the zones are isolated, and with their power backup, servers, networking, everything is isolated. But it gives you a redundancy if you are, if your application are distributed, right? So you can choose two reasons. So I'm not going deep into the reasons and zones, but this is all over the regions and zones of Google Cloud. So I was talking about why Google Cloud VPC is different from the other cloud, and the reason is that the Google Cloud is a global service, is a global resource, right? If you are coming from AWS VPC, there is a regional, and in Azure also there is this is a regional. And why VPC is global in Google Cloud is because of Google Cloud Network, right? So this is the Google Cloud Network, and if I say that Google Cloud Network is probably the best network in the world, then I am not wrong, because Google has heavily invested into their network, right? And see these green wire and all these blue wires are basically the optical fiber cable underlying in the sea, and this is Google owned fiber optical cable. This is that where Google has invested a multi-billion dollar, right? So this network, it spans all over the regions, which makes your network global. It's like you are sitting in the hall, and you have underlying LAN cable over there, and everything is connected. So treat this this global this global map as a whole, right? Where everything is connected as a LAN. So all the wires, all the optical fiber cables, their data point are connected by their own cable, and that is why Google offers VPC service as a global service. Okay, so as I said, um, Google software defined global network underlying network virtualization stack, and the stack is called the Andromeda, right? And the network service, along with the open innovation, provide the foundation of securely delivering a diversity of workload and the service on the Google Cloud platform. So, next slide. Okay, so Google's global VPC. So if you look at this picture, if your resource, let's say your VM is deployed in one region, let's say in US West, and your another VM is also deployed within the same VFC but in another region. So your VM can talk to the another VM just like they are in the same location. So that's how the Google Cloud VPC network provide the latency, right? So basically, a single Google Cloud VPC can span multiple regions without needing to communicate across the public internet, and it provides the same private gateway for your on-prem hardware but also gives you a global scope between regions and shareable configuration between your projects and real-time logging to monitor your application. Okay, so the most impressive feature of GCP VPC system is that it allow your VMs to communicate across region without needing the extra overhead of VPNs to do so, right? Uh, One second, sorry. Okay, so this is all done using the same global underlying network that powers Google's product like YouTube and Gmail and search. So this means that Google handles your traffic under the hood by dynamically advertising routes across the VPC, and this is abstracted from the user. Okay, so what is VPC network? As I said, a virtual private cloud VPC network is a virtual version of a physical network that is implemented inside the Google's production network, and the technique that they use is called the Andromeda. So VPC network does the following: likes provide the connectivity to the VMs. It offers native pass-through load balancer. It connects the on-prem network to your Google Cloud with the help of with the Cloud VPN or Cloud Interconnect, and they can distribute traffic from Google Cloud external load balancer to the backends. So this is the VPC network example. Um, so it say that you have region US West one, you have region US East one. We have two subnets, subnet two, subnet three, and in US West, you have subnet one. The network is only a single network, right? But subnets are spanning over the regions. So your compute engines, subnet one is, if you take a look at the subnet one, 10.240.0.0/24, which is in the US West one region. So two VM instances in the US West 1A zone are in the subnet, and their IP address both come from the available IP range, the address in subnet one. Similarly, subnet 2 and the subnet 3. So they can my share. Where is that slide? Okay, so you can see that their VM can talk to the another VM, though it is separated by the region, but it can talk to like they are in the same location. So it provides a greater latency, right? Right. Since as I said, VPC is a global resource. Each VPC network consists of more IP address range called subnets. So in Google Cloud, do you don't need to define a range for a VPC network. Just like in AWS, where you create a VPC, you define some IP range, and then those, and within that IP range, you create your subnets. But that's not like in Google Cloud. In Google Cloud, you just create your VPC with any name, and when you create your subnets, where you define your IP ranges. Okay, so you can define your IP range at the subnet level. So you can create two types of subnet. VPC support two types of subnets, so which is one is IP4 and second is IPv6 with IPv4 and IPv6 subnet range. Right, so you can create a IPv4 subnet range, a primary IP range and a secondary IP range. I'll cover this in separate topic because in our upcoming videos, I'm going to cover each and every component separately, and maybe there we will deploy and deep dive into each and every component of the VPC network. We'll also perform the demo within the console, or we can also deploy with the Terraform. So I'll cover this. Uh, so this video is this only talks about the overview of the overall components of the VPC network. Okay, so this is reserve address. I'll talk about this later in this video. So basically, the reserve, when you define a subnet, let's say you have defined a subnet of 10.1.2.0/24. So in this, whatever, so we will have some host IP, right? But out of those host IP, these four IPs are reserved by the Google Cloud. The first IP is the first address of your primary range of your subnet, which is 0 and used by the network only. And the second IP, 10.1.2.1, is used by Google Cloud for default gateway. The second to last address IP is range is basically used by the Google Cloud for future use, and the last IP address is IP range of your subnet is used for the broadcasting. So whenever you create a subnet, these four IP address are by default reserved. Okay, so please take a note of it. Okay, so let's see uh, uh, analogy of how VPC looks like in a real world. If I compare it with some example, let's say let's draw. Okay, so you have, let's say this is your VPC. Okay, I'll type it here. uh, okay, so if I am drawing the an analogy of how VPC network looks like, let's say this is your society, right, where you lives, right? And let's say this is your VPC and your society. What you have let's say you have some buildings, right? You have some buildings. Okay, I'm just giving you an example, right, so that you better understand what is VPC network, what is subnets, what is firewall, routing, internet gateway, all this thing. So let's say this is your society, like, and in society you have multiple towers, right? And then you also have a main entrance gate, right? So this is your main gate. Okay, and this is your tower, right? Or let's say in society, let's assume that this overall society is your VPC. Okay, is your VPC. Let's assume that, and this main gate treat this as a internet gateway, right? This is main gate. So and this is your society. This is your building. Treat this as a subnet. Okay, so these are your subnet, right? This is subnet. Okay, so so in your tower you have some flats as well, right? So let's say you have flats. Let's take it small. You have few. Not able to do it. Let's point this. mm, Let's say here you have some flats. Okay. Here also you have some flats. Okay. And every tower, if you are living in a society, then you have seen that in every tower there is a security guard sitting over here, right? There is a security guard here. You'll find it every tower. So you can treat those security guard as a firewall, right? They're a firewall. So this is your overall VPC network, and under your VPC network you have multiple subnets. Let's say if your subnets has a multiple, treat those flats as a VM, right? So let's say this is your VMs. If you wants to talk from one flat to the other flat in a different block in a different building, then what would you usually do? You basically go to your security guard will definitely check with you, like from where are you coming, which flat number you are coming, and to which flat you are going. Okay, so these security guard are treated as a firewall in the Google Cloud, right? And these are the subnets. If one subnet wants to talk to the another subnet, has to go through the firewall. If this subnet wants to talk to this subnets, obviously you need to go through your security guard, which is a firewall. Okay, and if subnet wants to talk to the public internet, it has to go through your main gate, right? This is your internet gateway, and it talk to your public internet, right? So this is how it actually works in a real world. There are a lot of example I can put in, but you can also define the routing. Okay, from where to go, from which path you want to go to the internet gateway. You can't take a shortcut, you can't take a shortcut from here, and you can't take from here. There is some routing that you need to define, and that path, you need to take to your internet gateway, or maybe you want to talk to your local subnets within the VPC. There are some defined routings, right? So this is how your VPC analogy. Just for your understanding, I made this a little diagram for to comprehend on this topic. Anyways, let's log into the console, and I'll show you how VPC can set up, and how VPC actually works. Okay. Okay, before we dive into setting up Google Cloud VPC, I just want to tell you or show you the comparison between the Google Cloud VPC and the AWS Cloud VPC, so that the people who are coming from the AWS background, they need to understand that why uh, Google Cloud VPC is a global resource and how it actually looks alike, when you implementing the same into the cloud. So here is the architecture. You can see that in on my left hand side, this is my Google Cloud platform where I have a global VPC. This is my global VPC. Okay, and in the global, which means my VPC spans all over the region, right? And I have three subnets, right? I have created three subnets. One subnet in Mumbai region, my second subnet in Delhi region, and my third subnet in the Singapore region. I can create multiple subnets within the same VPC. You will also see that this private, if my subnet is in Mumbai region, which means it spans all over the zones, right? So my subnet is my regional resource. Like all these subnets are the regional resource, and my VPC is a global resource, right? So if my workloads, which is hosted in Mumbai region, wants to talk to the workloads in Delhi region or Singapore region, can easily talk to each other. The only thing that we must allow the firewall rules, okay, right? So cloud firewall rules you need to deploy. Maybe you'll deploy firewall rules here, the interest firewall rules. Let's say that your source is the source of your Mumbai subnets, and your destination is your Delhi subnets, can be allowed, right? So whatever workload that is deployed in Mumbai region are allowed to talk to the workloads in the Delhi region. And same here, you can also deploy the firewall rules for Singapore, right? So the key thing here is that this resource, what I just wanted to emphasize here, right? Is what is global service and what are regional service and what are zonal service. So you must be aware of that, right? In AWS cloud, on the right hand side, you'll see that you have a region. Let's say you have a Mumbai region, right? And Mumbai region, you have a VPC network, which is a regional, right? This VPC network is only spans over this Mumbai region. This is not a global service, right? And then in the region, you have a availability zone, similar to zones, right? In our Google Cloud. So you have three edges, right? And you also notice that whatever subnet that you will deploy here are zonal, right? Subnets in AWS cloud or any other clouds are regional resource. So you can see that you have one single VPC regional, we have three zonal subnets. And if your VM wants to talk to you, from one AG to another AG, the only thing that you need to open the security groups, right? And if you want to move to the another region, let's say for Singapore region, you need to create another VPC. That's how it works in the AWS. And once you create, let's say, uh, you have another VPC. Let's say this is in Delhi, okay, and this is your VPC, and this is your VPC. And if one VPC wants to connect to another VPC, then you must create something like transit gateway over here, right? Some sort of peering if you want to. All this is all depend on you. um, Here also, if you want to create another VPC, and one VPC wants to talk to another VPC, then you have something called VPC peering, right? Same concept here as well. What else I can show you here? um, like we have a cloud firewall rules here in Google Cloud. Here we have a security groups, right? Security groups apply on the instance level. So you will have the security groups which act as a firewall rule. Okay, this is all about the comparison. Let's go to my Google Cloud Console, and here I will simply set up a simple VPC network. I'm not cover everything, but I just want to show you how can you create a VPC network over here. The moment you log into your Cloud Console and go to the VPC network, you just need to select your project, you'll see a default VPC network. This default VPC network is a default network that is provided by the Google. I'll see I have 39 subnets. This is auto mode. I have 6 inbuilt firewall rules, and the global dynamic routing is off. So if you just click on that, so you'll see these are the auto subnets, which is by default created by the Google Cloud. And this default VPC is basically used for, if you want to quickly deploy your VM instance for some POC or for some test purpose, then you don't need to create a VPC network. You can simply use the default network and deploy your workloads in any of the subnets, any of the regional subnets, right? So these are the default subnets. If you want to deploy in US Central, this is the default IP range, 110.128.0.0/20. So you can imagine how many hosts you can host in this IP range. So in real world, you don't use this default VPC network because sometimes it conflicts with your on-prem network, and when if your IP range conflict, then there is a problem, right? So in the real world, the default VPC network by default, you must remove it. Okay. Now, if I want to create my own VPC network, it's very simple, right? Unlike AWS or VPC, AWS or Azure, you don't create. No, one second. You don't define any IP range to that VPC. You simply just name the VPC and say custom VPC, and then here you can either click on automatic. It auto generate some random subnets for you, depending on the locations, depending on the regions. But I don't want to create in the auto mode, so I'll go with the custom mode. So add a new subnet. Let's put it subnet 1. Let's say I want to put it in, uh, let's make it in US West. I want to use this now, 10.255.188.0/24. Any IP range that you can accommodate here. If you click on private Google access, it means that if your workloads wants to access to Google Cloud Storage or BigQuery, which is a public API offering or public API which needs internet to access those API. So if you click it on, your workloads will go through the private network only. It will never leave the Google Cloud network. It will never hop up for hop up on the internet to access the public APIs. So I don't need this as of now. I don't need this. I just clicked on off. Flow logs, I don't need it because flow logs are basically the logs and to check the performance of your traffics coming from VPC or going through the VPC. So you can check, and all the logging things are reported or logged into the stack driver, or which is a managed service by Google Cloud. Click on done. Okay, so I don't need those firewall rules. I'll talk about this firewall rule later. And simply just select the dynamic routing more regional, and no DNS server. Will talk about this later. This maximum MTU, I will talk about this later, once we deep dive into it. Simply just name your VPC, create your subnet, define your IP range, which region you want your subnets, select the dynamic routing more regional, and then create it. Okay. This item contains, okay, what is the error? Oh, I have this subnet. Okay, I just need one subnet only. So your VPC is still creating. It takes a couple of minutes. So meanwhile, on the left hand side, you'll see that under the VPC network, you'll see some of the option like you can create the VPC network, the IP address, bring your own IP, firewall rules, routing, VPC network peering, right? How can you connect to VPC? Your shared VPC, this is something the extended model of VPC, and serverless VPC access, packet monitoring, all this component we are going to cover in our upcoming videos for sure. But as of now, I are focused on the overview of this VPC network. So you can see that VPC2 has been created with one subnet. The mode is custom, no firewall rule, the global dynamic routing is off, right? And we have the MTU 4060. So if you see here, this is the same description. Okay, you have one subnet. This is a defined range. This is the reason. No secondary IP range. This is my gateway. And what else? Let's click on subnet one. So you'll see that the type is internal. It's IPv4. Private Google access is off, and the flow log is also off. If you click on static internal IP address, we haven't resolved it, but I'll show you in later on. No firewall rule as of now. We have not created any firewall rules, so by default, nothing is allowed to talk. Okay. Okay. Routes. Click on US just one view. So these are the default routes when you create any VPC. So the first route is saying if anything within the VPC wants to talk to this destination, the next stop is VPC2 only, right? So let's say I have two VMs within that VPC. If one VM1 wants to talk to VM2, the IP ranges are taking from within the range of the VPC of the subnet. So it takes the next stop VPC2. Okay. If my VM wants to talk to the internet, right, it go to the default internet gateway as I show you, right, in the analogy, right, how your VM can talk to the public world by taking the main route entrance, right? So that main route entrance is called default internet gateway. In AWS, it's also there is internet gateway. So Google takes care of this routing part. That is static. If you want to create your own on routing, when you connect with to your on-prem or something like that to any other cloud over the VPN or interconnect, will define your static routes. Okay, so routing is a very complex topic, and I'll take a separate session on that routing part in details. Okay, we have no network peering as of now because we have a single VPC. Private service connection, I'll talk about this later. Okay, so as of now, your VPC2 has been created, and if you want to deploy any virtual machine, you can create an instance. Let's take it web one, and my subnet to, since my VPC is global, I can go to any region, but since my subnet is deployed in US West 1, so I'll go to US West 1 only. uh, where is that? It's there. Okay, I'll take any zone right as of now. I'll take a small size. And when you come to, so firewall rule, if you want, you can allow HTTP traffic. If you the moment you click on this, it will create a firewall rule for it. But I'm not going to create it. I'll show you how to create it in my upcoming session. I'm just simply showing you how to deploy a VM to your custom network, right? So this was the default network. I'll select VPC2. Okay. So subnet 1, this was my IP range. Okay, this is my primary IP, the internal IP range, and this is my formal or public IP, right? As I said, I'll talk about this premium and standard version later, but for this moment, like this premium is something. If you just hop over to this question mark, it say the traffic traverse Google's high quality global backbone, entering and exiting the Google edge peering point closest to the user. It means that the traffic which are living or coming to this VPC network it will come via the Google fiber optical cable or Google own network. So it will reduce the latency, uh, right, and it will give you a greater bandwidth, right. Standard is like, again, if you hop over it, it will leave from one network, from one network to another network, which could be owned by some other, some other provider. I'll talk about this later. As of now, just done it, and create it. I haven't deployed anything here, but let me see if I can deploy something, or leave it. Just maybe next video I'll take it. I'll install the web servers. So it says that US West 1B doesn't have any enough resource. So let's delete this. Okay, create a new instance. Take it as instance one and make it as a small advanced networking default PC2 subnet this. Done. What I'll do, I'll also install some startup script. One second, let me find it if I have any. Let's see if I'm able to. And let's also allow HTTP traffic. Okay. Hopefully it should deploy. Okay, you can see that my instance is deployed in US West 1A. This is my internal IP. This is my informal IP, external IP, and this is my VPC2 network. Right, this is what my custom VPC. Right, and I also deployed some web servers here. So if you click on that, you can see that I'm able to access my web servers from my custom VPC network, because this VM has got external IP. That's what I'm able to access it. If I remove this external IP, you won't be able to access it. In order to access this machine without public IT, you'll have to use the load balancer in a public subnets, and then from the load balancer you need to attach this instance. So that's a separate topic. I'll cover this in another video. So let's go back to the VPC network site. So I remember I enabled a firewall, HTTP firewall. The moment oh, one second. If you go to Um, if you goes to my VPC2 and if you see the firewall, you'll see that this machine has automatically created that firewall rule has automatically created a rule for me. If you click on that firewall rule, because I have clicked the HTTP, right, during the creation, so you can see that it has also tagged HTTP. I'll cover this, like what are the targets, how do you use the firewalls. A little complicated in Google Cloud, but if you understand the fundamental of fundamental of firewall rules, then it is pretty easy. So you can see that, like under this firewall rules, which instance are currently applicable, right? So you can see that this is my, if you click on edit, you can see that um, the direction is ingress, priority is 1000. Okay, and the target is HTTP server, which is my target having this tag. The source filter is internet. From internet, you can access this virtual machine on port 80. That's why we are able to access our web server, and the port number is 80, right? So let's say if um, I create a quick firewall rule just to show you what exactly the firewall rule is. If you try to SSH into this VM from my public, from the internet, it will state away denied, right? You can see that this pop-up has been appeared. It says consider adding a firewall rule to allow ingress from cloud IP or TCP forwarding. I'll cover this cloud IP later. This is a very important topic, but as of now it is saying that that if you want to connect to your instance on internet or internal IP, then you should use cloud IP and use this and allow this firewall rule. But as of now we don't want to use the IP. We want to directly access this machine over the SSH port. So let's cancel this. Go to your VPC. Okay, go to your VPC network. We will allow some the SSH firewall rule. Go to firewall, add firewall. Let's allow SSH. So we are allowing SS allow SSH port 22. Okay. This is my network, right? So you want to open ingress. The direction of the traffic should be ingress, right? Because something is coming to my VM, right? So action on match this time will, let's say, all instance, and my source filter is 0000/0 internet. And I'll cover this later. What is second source filter? What is destination filter? Now I'll take a specific port 22, right? It's it's very easy, right? I'm basically saying allow SSH connection from the internet on port number 22 to all the instance in the network. I have not specified the tags, not a specified service. I'm saying all instance, whatever, how many instance you have in the network, all will be allowed. Since I have one, so let's create it. All right, so you can see my Indus firewall rule has been created, and see this one on port number 22. Source, if you see the source, click here, see this is my public source. So now this time if you connect to SSH, you should be able to. All right, you can see that I've been connected. Right, we can run you any commands. So that's so because of the ingress firewall rule, I'm able to SSH into this machine, and because of this firewall rule, I'm able to access my web servers over the internet. So you can see that, right? This was my web server. All right, so that's it for now. I hope it this video gives you great information and it brings some value to your knowledge. If you have any question, please feel free to comment in the comment section. Uh, Next, we are trying to cover more on VPC component like VPC firewall, VPC peering, and VPN interconnect. Again, interconnect has partner interconnect or dedicated interconnect, and the most important share VPC. Will also cover the demo and the overall things around the VPC network. If you go to the here, VPC network has this list. What are the IP addresses? How can bring your own IP? What are firewall rules? Routing, which is very important. Network peering is also very important. How your standalone VPC can connect to another standalone VPC. Shared VPC is something that is again a VPC, but it's shared in nature. So I'll show you how shared VPC change the overall architecture and how it helps the enterprise and large organization to solve the complex network infrastructure. So this is very important, right? I'll show you. Serverless VPC access is also very important. If I'll show you like how, why, and how serverless VPC access can be used. Packet monitoring is again one of the important topic if you want to troubleshoot any issues, or if you have worked on packet mirroring in your traditional data center private network, then you must be knowing how packet mirroring works. So lots of things to cover in around VPC network. So in the upcoming videos, you're gonna learn a lot of new things, and people who are beginner or coming from the another cloud like AWS or Azure, this is going to be a great learning sessions or series. So stay tuned for more videos. Thanks for watching. See you again. Bye bye.